Hello, everyone, and welcome to tonight's meetup with the AWS User Group Bangalore, which is also a joint meetup with the Cloud Native Bangalore group. So, for today, we are doing something a little different from the convention, and as it's like a joint meetup, we are diving into some of the popular, actually, three popular projects, which is Kubernetes, Falco, and Flux in CNCF minute style, where the speaker will try to introduce the project in a few minutes and explain what its use cases and all with a small demo. So for today's demo, we have someone special who is Saiyam Pathak, someone who needs no introduction to the community space, and who's also a CNCF Traefik Ambassador and who's also certified in CK, CKD, and CKS, and he's currently working as a Director of Technical Evangelism at Civo with a focus on defining the Civo cloud platform for simplifying Kubernetes and making it accessible for the developers. And when he's not coding, he contributes to the community by writing blogs and organizing the local meetups for Kubernetes, Rancher, Influx, and Seeds. So we are super excited to host you once again. And without further ado, over to you, Sayam. Take it away.
Awesome. Thank you so much, Ransi. Ransi is an old friend of mine, and he asked me, to do this particular meetup, and it has been kind of long due for us to do this, but here we are. And today I have something which is not there on my CNCF minutes playlist, but it is in the CNCF minutes style, as Ransi mentioned. So this will be exciting. So please make sure you share the share the stream with your friends, and everybody can learn. And it's bit of like handwriting, bit of all the slides that I have already pre-prepared. And make sure you kind of create Twitter threads on the learnings that you do, because then I'll understand like you have learned something with the CNC minutes. So already Ransi has introduced me, so just quick introductions. Like my name is Saiyam Pathak. I am a CNCF ambassador. I'm very active on Twitter, so if you want to connect over there, you can connect. My DMs are always open. And I'm a CK certified, and also I'm an SME for KCNA, which is the latest Kubernetes certification in the CNCF ecosystem. You can read about that. I think till 28th of November there is a kind of big sale, KCNA 250, that gives you massive discount on certifications. So if you are new, so you can take that. I'm working as Director of Technical Evangelism at Civo. So you should definitely check out Civo. So civo.com/sign up, and you'll get a managed Kubernetes K3s over there. This is my YouTube channel, so make sure you subscribe to my YouTube channel, sayampathak.com/YouTube. This is the book that I have written for CKS certification. And just to let you know that there is a 50% discount running for the Black Friday and Cyber Monday sale. So just use the coupon Black Friday, and you can buy any of the edition, like silver edition or the gold edition of the book. This book is for the Kubernetes CKS certifications, certified security specialist. So with that, we'll move to Kubernetes. So we have three projects today. One is Kubernetes, and one is Flux, and another one is Falco. And they both kind of cover different domains, but I kept Kubernetes just because to set the context right, so that if you are completely new, so you still get a lot from this particular session. So you'll get that. And let me just switch on the light so that we can remove the flickering of it. Cool. Okay, so Kubernetes, I think it needs kind of no introduction. Kubernetes is a CNCF graduated project, kind of the building foundations of the CNCF ecosystem. Kubernetes.io is the documentation, and you can see like it is a production grade container orchestration system. So if like the containers are there, and you can kind of use any technology for container. Most popular one is the Docker one out there, but now the container D and the runtimes have been changed. So you have Docker and stuff. And when you want to orchestrate the containers, and want to productionize it at scale, and want to use the features like automatic deployment, scaling, and all its management, then you need some orchestration system, and Kubernetes is the beast out there. So what we'll do is, where did this go? Yeah. So we'll study about Kubernetes in a way. We'll go through the architecture, basically just to understand what actually is there in Kubernetes and how you can use it. So Kubernetes is orchestration system. Just to set the context right, you have an application, you have containerized that application. Now you want to deploy that application. Now this is just one. Say that you have hundreds of microservices building that application. Now you want to deploy hundreds of application. So these will be deployed as containers, and these containers has to be managed in such a way that they are deployed on the right set of node. They are auto healing themselves. Like if one of the node goes down, or infrastructure where it is running goes down, then it automatically put that container in another kind of infrastructure. I'll tell you the terminology I'm saying. And then you have your the management. So scheduling is done, then you have the management of nodes, then you have the metrics, the plugins that you can do, and then you have the extensibility. So when we talk about Falco and we talk about Flux, you will see the power of Kubernetes with respect to the extensions like the controllers and the custom resources. And then you have okay, now what we'll do is, now we can start. So we have the infrastructure. Now infrastructure is basically your you can use your cloud provider or your laptop. So basically anything where you are working. So you have your infrastructure in some cloud. Let's say it's in Civo. So you have compute nodes over there. So you have the virtual machines. So you have virtual machine 1, 2, and 3. Now when I talk about nodes in Kubernetes, they correspond to these virtual machines. So nodes correspond to the virtual machines which are running in the cloud. The nodes can be the bare metal machines, they can be the Raspberry Pis, they can be the hardwares, your old laptops. So it can be anything, but just for the simplicity, nodes are the virtual machines in this particular scenario. And what we'll be doing is, we have one control plane and then we have worker nodes. So we'll discuss two major components of Kubernetes in Kubernetes architecture, control plane which is the control plane and worker. So we'll see how actually something which is called a container runs in a Kubernetes cluster. So obviously, the first step would be to set up the Kubernetes cluster. The first step is to set up. We'll obviously not go through this particular thing, but I'll quickly show you in a demo how you can do that. So set up a Kubernetes cluster, and then we run the pod. So we run a pod using command line called kubectl, kubectl, whatever. Kubectl run nginx hyphen hyphen image nginx. Now you don't have to understand anything about it at the moment, but after I explain the architecture, you should be able to tell what this particular command does. Now obviously this kubectl gets installed onto your node. So on the control plane, or when you install the Kubernetes cluster, you will get something which is called a kube config file. Now you can use this file from any system, and you can use this tool plus combination of this tool and kubeconfig file to run the Kubernetes, to connect to the cluster. So let's go to the architecture. Now you have control plane. So this is the control plane. Now in control plane, there are different components. Now as soon as I run the command kubectl run nginx, what it does is it talks to the API server. So any request goes to the API server. So API server is the kind of brain behind Kubernetes. It is the component that talks to all the other components within the Kubernetes cluster mostly. Then you have the scheduler. So now a request came to kubectl. Hey, Kubernetes, I want to run a pod with the image. I want to run a container. Basically, you are saying I want to run a container, but in Kubernetes, the fundamental unit is pod. You can see on the right hand side, the pod is actually nothing but one or more containers, set of one or more containers. So you have a pod, you have a container, and now you are saying Kubernetes, hey kubectl, please run the pod nginx with the image Nginx. Now this is the name. So it tells this particular information to Kube API server. Now scheduler says, scheduler obviously asks API server, is there anything to schedule? And API server tells, yes, there is a pod that you need to schedule. And it also checks the resource limits, etc., the configuration that you can do. All the configuration is done either via the imperative way, which is this, or via the YAML file. So YAML file is, I'll show you what the YAML file looks like. So they can be done via this or the imperative way. Now you have your API server scheduler. Scheduler will find the best fit node. So these are my two nodes, and it will find the best fit node for this particular pod with respect to the resources which are there defined in the YAML file. If not, then it will also try to do, with all the scheduling algorithms, it will try to find the best fit node. And then once the node is kind of finalized, it keeps on communicating with etcd to store the state of the pod, like it is there, in which state it is currently there. So this is kind of the internal database to etcd to store the key value database that stores the state of the state of your Kubernetes cluster. Very important, obviously, with respect to what is running in the cluster, it has to match the desired state and the state that you have mentioned. So desired state is what you need, and the actual state is what it is there, and keeps on getting compared, and then it automatically fixes if something is wrong. Example, there are like objects which I'll come later on. So there are some objects which are there in Kubernetes that you can create, and you will define the state for that in the spec section, and that is maintained by the Kubernetes cluster. That is one of the powers of that. And now you have the controller managers. So controller managers, there are a lot of controller managers like replication controller manager, daemon set controller manager, deployment controller manager. So these are actually the Kubernetes object. So for example, daemon set make sure that your pod runs on every node. Deployment make sure like the number of replicas that you have mentioned in the deployment always runs. And if you say like I want 2 copies of my application to run, and you set the number of replicas as 2, and now if one replica goes down, then your deployment controller is responsible for making the replicas 2. So that's how it does. Now your actual workload doesn't run on it can run, but it should not run. You should always keep your control plane isolated and keep the control plane components over there, and not run any of the any of your workers or any of your workloads in your control plane nodes. And you should always run your control plane nodes in the worker. Sorry, you should always run your workloads in the worker nodes. Now in the worker nodes, there are components like kubelet, kubeproxy, and pod. So kubelet is something which keeps on communicating with API server. Hey, is there anything that I need to run? Now API server got from scheduler that you need to run a pod, and the API scheduler told the API server that this is the node that I want this particular pod to be scheduled. Now API server tells this kubelet, hey, there is this pod with this particular image that you have to run. So you need to run nginx pod and give me back the information. So what kubelet does is, now kubelet talks to the container runtime. So kubelet will talk to the CRI, CNI, and the CSI. So it will talk to the container runtime, and the container runtime, which can be Docker, which can be container D, and which can be cryo. So all these runtimes can be configured at the install time when you're installing Kubernetes. So those will talk to the registries out there. Container runtime will be talking to the registries, getting the image and running that, and then telling the kubelet tell the API server, API will persist that in etcd. So that is how your pod is running inside the Kubernetes cluster. Kubeproxy is managing the kind of networking and IP tables and all that stuff, so that your pod to pod networking and all that stuff is maintained in your Kubernetes cluster. So that is how your overall architecture looks like in Kubernetes. You have master or a control plane node. We should use this make a habit of using the kind of control plane terminology. So a control plane node and the worker node. So control plane node will be having API server, scheduler, cloud controller manager. There are other like cloud controller managers also there, which is specific to the clouds. And then you have the kubelet, kubeproxy, container runtimes, pods, not the runtime but the pods, which is there in the in your worker node. Yeah, obviously the runtime is also there. A runtime can be any, which is Docker, container D, or cryo. So now if you see kubectl run nginx -- image nginx, you should know what it is doing. So that is what, on a very high level, what Kubernetes is. Now obviously Kubernetes is huge, the ecosystem is huge, I cannot cover that in the CNCF minutes, but uh, there are a lot of Kubernetes objects that you can create, like pod deployment, I told you replica set, daemon set, and then you have a concept of volumes, you have concept of RBAC, which is responsible for authentication, authorization, and admission. Then you have your security, which is it comes under security. Then you have the monitoring, like slash whatever the metrics it exposes in the Prometheus format. Then you have your configuration files, like the Kube API server flags and the controller manager flags. And then you have your kubelet arguments while setting up the cluster using kubeadm cops and whatnot. For that, now this particular slide, this particular diagram was from my course, which is there on Civo Academy. So this is the complete course. It is obviously free of cost, so you can learn Kubernetes from scratch. And you can see it covers before Kubernetes, some of the Linux commands, introduction to containers, then Kubernetes introduction, Kubernetes concepts, then you have the setup, how to set up Kubernetes using containerd, and also on Civo Kubernetes. Then what are Kubernetes objects? There are, like, I have made it extensive. Then Kubernetes networking, Kubernetes services, volumes, and config security I have covered in detail. Kind of very interesting, all the examples with the whatever is you can see on the screen. So make sure you learn that. civo.com/academy, completely free of cost, no credit card required to learn from this academy. So what happens is, in Kubernetes, you can either create your cluster or you can use any of the managed offerings. So like this, Civo provides a managed Kubernetes offering. I can just click here and you can see this is a managed cluster based on K3s. So you already get by default. Or if you quickly want to test, what we can do is, K3s is a distribution of Kubernetes, just in case. You just go to the Ubuntu playground and you run this particular command, and you'll get a single node K3s Kubernetes cluster with you. So K3s again is a Kubernetes distribution. It's a separate topic. You can go to my YouTube channel. Everything is available over there. What actually K3s is, but this is CNCF minutes for Kubernetes. I just wanted to show you a demo of how, like, Kubernetes would be there. Now in K3s, everything is a single process, but I don't want to confuse you at the moment. So you can use that. Now what happens is, now you know what Kubernetes is on a very high level. Now you know what Kubernetes architecture looks like, what control plane and these components look like. Now we go to our next topic, which is Falco. Now Falco is a pretty interesting project. It is cloud native runtime security tool, and it was kind of created in 2016, and it is donated to CNCF on 2018. It is a CNCF incubating project since 2019. So the growth has been like multiple folds in terms of the usage, in terms of community contribution, in terms of how it is adopted. Falco is very much relevant for the CKS certification exam as well. You'll find a question over there related to Falco. So I think that's what makes it a very important tool. Now what is this beautiful thing? So Falco is by definition the cloud native runtime security project, and is the de facto Kubernetes threat detection engine. Now when you talk about the cloud native landscape, so in the cloud native landscape there are there are two, you can say, domains or sections. One is the prevention and other one is the detection. So prevention is changing the behavior of the process, like, killing the process and all that stuff. And the tools over there is the seccomp, app armor, all those are there. Now Falco sits under the detection. So detection means monitoring the process, analyzing it with respect to the alerts or the all the fancy rules or the policies, whatever fancy name you want to give, and then alert. So Falco, audit D, etc., they kind of fall in the detection. Now it is not like you should only use Falco or you should only use app armor. You should be using the combination of both to define the best cloud native security landscape architecture for your application and infrastructure. Now that's how it should work. Some of the stats first. So like I told you, 42 100 plus GitHub stars, 120 plus contributors, 35 million pulls on the Falco one, and the 3.5 millions over the Sidekick. Sidekick is kind of another project inside the Falco repository, Falco GitHub. I think Thomas is the one major contributor behind the Sidekick. So community contributed. Now, whenever your application, so I told you, like, you have a node. In node, you have operating system. In operating system, you'll be having a kernel. So what happens is, any application that needs to do something, it communicates with the operating system, or it communicates using the kernel. It communicates to the kernel using the syscalls, which is the system calls. So all the application, in the end, whatever happens is in the kernel layer. So whatever is happening is in the kernel layer using the system calls. Now when we go to the architecture, it will be more clear. Falco. Falco has made use of these syscalls. So it sits at the core layer, which is the kernel. So it takes the syscalls from the kernel layer, parse the system calls, check against the rules that are defined by you. There are n number of best kind of default rules as well, but you can obviously create your own rules, and then alerts on the rules violation. So that's how Falco works. But we'll see now how Falco actually works. So you have your application, then you have your Kubernetes layer, you have your operating system, you have operating system, and then it will be your application goes here, it goes here. Obviously, it is sitting on the operating system, and then it is communicating to kernel via the syscalls. Now Falco has, when you install Falco, there are the drivers that gets installed. Now those can be, those drivers are the kernel module or the eBPF probe. And now the kernel module is the default one, and for the newer versions of the kernel where your eBPF is there, you will have the eBPF driver over there. And so if it's the kernel module, it will use ring buffer. If it is eBPF, it will use eBPF probe. Now these kind of they work and translates the system calls to the Falco libraries. And now they are added, these are the Falco libraries. Now they kind of adds, and you can even add the plugins. You can even use some of the plugins like the cloud logs or the API. So these translates the system calls to the Falco engine using the libraries. And there are additional plugins that you can use to enhance the functionality of the existing libraries. But these two are the, I think, more than enough and doing all the stuff. And the Falco engine will check the rules. Now the rules can be defined in the YAML files, or it can be as the Kubernetes events using the audit logs that tracks all the access to the Kubernetes API server. And they go to the engine, and it checks against all the translations of the system calls which is coming from here. And after that, it can give the output in the form of, like, if any alerting is there. So alerting will be happening in the form of outputs can be HTTP, grpc, Prometheus, std out. And if it's HTTP, it can also this is where the Sidekick project is there. Now HTTP can be pointing to this Falco Sidekick. It has a fancy UI as well. And the Sidekick has more than, I think, 40 plugins. Like, it can send notification to Slack or S3 or serverless toolings or Loki or Influx. I mean, there are many stuff where it can send the result to, and then you can see in the fancy Grafana dashboards and get all the alerting. So that's how you will be kind of getting the uh, Falco is working. So from one call that is getting tracked, that is how the tracking is happening in the Falco. That is how the Falco sits in the user space, and this is the kernel. This is where the kernel space lives in, and your drivers are the major portions that are translating the syscalls, which are made understandable by the Falco engine, and makes it check against the YAML and the rules which are provided. So that is how Falco works. and its installation is kind of simple. Like you can install it on Linux, and Linux it will be installing Falco, the driver and the default rules in slash etc slash Falco. We'll see that you can install it as Docker. You can have it deploy it on Kubernetes. It I think deploys as a daemon set, and you can build from source as well. So there are different installation methods. um so this is falco.org. Make sure you kind of see all the links. This is falco.org/labs. So this particular labs give you the introduction to Falco, like installing Falco with Docker and detecting a threat. This particular labs installs Falco on Kubernetes cluster, and this particular lab talks about the Falco sidekick. So I think you should definitely check these Katakoda scenarios integrated. uh, I mean, they take 10-15 minutes for each of the labs, or maybe 20 depending on the experience. So you can definitely take these labs. And this is what is called Falco examples. So this is how a Falco rule will look like. So Falco rule, I told you, is a YAML file. It has the macros, and it always checks the condition, and based on the condition it will giving you the output. And then I'll show you like all the files over there. Now, very important from CKS point of view, supported fields. Now make sure you know this particular URL, or you know how to find it, because in the exam you might be asked to change the output. For example, here the output is username, container ID, and container name. You might need a time. So how to have the time? So you can see evt.time can give you the timestamp when that particular thing happened. So I think this is very handy, the fields and the outputs to manipulate and get the exact output that you need on whenever any of the condition is not met for a particular rule that you have defined in the falco rules.yaml file. So that's how it works. I will quickly show you the demo. I need to kind of reshare my screen. So this is the one. I hope you are able to see the screen. Now I have already installed Falco on this particular system, and it is using the simple commands from the installation. I can show you that. But what happens over here is cd/etc/falco. This is the Ubuntu instance. These are the default files that it already creates. So you have falco.yaml. So now this falco.yaml will tell you what all things are enabled, like grpc is enabled, your http output is not enabled, and your your files output is not available. You can have it write to the files. Syslog is enabled, so we can see it in the syslog output time and some of the falco kind of settings. Now let's see the other files. So you have Falco rules.yaml, and yeah, in the Falco.yaml, just one thing, like from where it is picking the rules. So it is picking the rules from these files. Rules files are these. So it is taking rules, local rules, audit rules, and rules T. Now, most important,
Saiyam,
yep.
sorry to interrupt. I guess you're not sharing the right tab, probably.
Okay, interesting. Share screen. I shared the window. Nice. Now you're able to see.
Yes, that's coming up. Yes.
Awesome.
Thank you.
So what I was telling is I am in the /etc. Let me clear it. So I'm in the /etc/falco. These are all the files that gets created by default. I am just checking the falco.yaml file, and this particular file tells me from where to pick the rules. So it is picking the rules from these directories, and you can define your own directories, but it is kind of suggested by falco itself. Like if you want to change or add any rules, you should definitely add to the local YAML rules, not the falco rules.yaml, because if something breaks and you're doing some changes, then the process won't start, and you might not see. So these are the default set of rules, and number of rules are there. I'll show you that. And these are the K8's audit rules which are there, and these it is the rules T. And it also tells you from the outputs where it is there, like the syslog output is enabled, the file output is enabled, which is false, so it is not enabled. So like this comes in the falco dot yaml file, so the configuration for actual falco server. Now you have the falco rules. So let's see this particular file. We'll try to be into that. So the thing is, Falco rules is huge. Falco rules.yaml is huge. It is coming with basic, I mean, a lot of very good default rules, like user unexpected terminal shell in a container. So if a user spawns a shell in a container, then this will be the output. A shell was spawns in a container with attached terminal and this particular image, and this was there. Now sometimes you do not want a shell to be spawned in a container, so you can have this particular rule and you can set the priority level. Or if it is just at the info level, you can change the priority level to info. If you want, like, it is okay for people to spawn a shell. Now there are a lot of things, like launching a privileged container is info, but you can change its sensitivity. And you have a warning of this, like running a shell inside a container is a warning. Then there are a lot of like macro conditions which are there, and which kind of enables, like Java processes are there. And then you have vworks, calico. So I mean, tons of rules are there already. Now there was error that I wanted to say. Yeah, modify. It's going too fast, just a second. Yeah, so modifying mkdir binary directories, and attempt to create a directory below the set of binary directories. Obviously when intruder comes in, they try to do some mischievous things, right? So anything here should not be permitted and should be error, and error should be triggering an alert, so that can be going to the falco sidekick and going to the another output plugins that you have configured with that. So like this you can edit or add the rules which are there. I'll quit for now. And then you have the audit rules which are there. You can obviously have a look at that as well. So this is what falco is. It will be running as a system d process, like system ctl status. Obviously falco is not running at the moment, so it is inactive, it is dead. What I'll do is I want to show you one thing. Let's have- okay, I'll grab this and name it cloud native. And what we'll go here is we will start falco and we'll try to see what is happening here itself. So falco has started, and you can see it has loaded the rules, loaded the configuration file which are there. It is loading the rules from all the files: falco rules, local rules, audit rules. So you can see it is running now. Now what we try to do is we try to run a container and we try to spawn a shell in a container, so we should see something like I put that as a warning, so we should definitely see it. I, oh, I am already inside a container, I believe. Yeah. So I am inside a container which is Ubuntu, and it is named as Cloud Native. And if I go here, you can see already a warning is coming. A shell was spawned in a container, and it gave me all the stuff. Now you might need a container name with that, so you can add container dot name, from where you can get from the fields that I showed you earlier. So that is how falco is running on a high level, and this is what falco is. So I'll now reshare my window. I can actually share the entire screen, it is okay, because yep, you're able to see the screen, right? Cool. So what we do is we have done falco. I told you about falco labs, I told you about the examples and this is how I installed it. You can install it on the helm, using helm repo update, having the falco, or you simple curl commands and apt installs on ubuntu. And this is what I just did. Syslog, obviously the system, the syslog was there because it was logging to outputs. You have seen that particular file was defined. So that is how falco is. This is what falco is. This is how it is installed. This is how you can monitor some of the events and do a lot of things. So I hope you were able to understand what falco is in the CNCF landscape and how it works. Working is very important to understand. Next is another interesting tool in the CI/CD ecosystem, which is Flux. So Flux is a tool for keeping the Kubernetes cluster in sync with sources of configurations and automating a deployment updates to the configuration when there is a new code deploy. What that means in very simple terms: say that you have simple manifests or customizations or Helm charts, um, and you have place them in github, and you define your cluster state in git. Now you have Flux will be is installed on your cluster. Now Flux will be installing a bunch of controllers on your cluster, which we'll talk about, and each controller has a specific work to do. And then it makes the changes in the source and syncs with the Kubernetes cluster. Now if you have created Flux and created the sync between the git and your Kubernetes cluster, then whenever a change is made, like you change the image, or you change the version of the image, or you change some code and you have some github action and change which changes the file, so this will automatically get deployed to the cluster. So Flux was like in 2017. It was actually before 2017, but in 2017 the deploy from git became very kind of popular, and 1.0 came. In 2019 it became CNCF sandbox, and then Flux 2 was there in early 2020. Kind of, this is the kind of the Kubernetes native, using the Kubernetes APIs, the CR, the custom resource definition, controllers, and all that stuff. Now it can, as of now it is CNCF incubated project. It became in 2021, and it syncs from git. It has image reference updates in YAML. So any images that are updated, like there is an image watcher, which I'll tell you, which can monitor the repositories, the registries, and let you know. And then you can manage the Helm releases as well. So Flux, who is Flux for? So Flux is for the cluster operators, like provisioning and configuring the cluster. So say you, whenever you provision a cluster and you have Flux and you want to have XYZ applications in terms of depending on the environments deployed to the cluster, we can have that. Platform engineers, you want to build a complete CD system for the developers, you can do that. App developers, obviously they will just rely on the CD which is being built by the platform engineers. So Flux is built on GitOps toolkit, and this basically, whenever you want to create a complete continuous deployment delivery system, you will be having the you will be using the complete custom resources and the controllers depending on what you want to achieve. We'll talk about more. So yeah, we have started already. So it is custom resources. So what you do in, so you know Kubernetes, right? So in Kubernetes, okay, I have specific objects. I can create pod, deployment, replica set. I can create persistent volume claim, and daemon set, config map, secret, and all those fancy stuff. So these are kind of native to Kubernetes. Now, what if you want to create an object and extend the functionality? You want to use the Kubernetes API. You want to use the scheduling powers. You want to use the RBAC. You want to use the all the powers of Kubernetes, and but for a custom Kubernetes object, which is called a custom resource. So you want it for a custom resource. Now here, Flux have created, or Flux is basically now a set of controllers that get deployed to your Kubernetes cluster, and each controller has a specific purpose, and Flux bundles these controllers together so that they can work in sync. So that's what kind of GitOps toolkit is. Set of controllers, Flux binds them together. Now you will be able to use the kind, the object like Git repository. So if you right now create kubectl, or you just write a YAML file of a Git repository, it won't work because there is no controller to understand that. But in Kubernetes, you have seen, right? In Kubernetes, like if I create a deployment, if I create a pod or a deployment, there is a controller. There is a deployment controller which is able to manage that particular kind. But there is no controller. So you create a controller and then you define the object. Now let's see how it actually works. So whenever you deploy Flux, there are different components. So Flux components have a source controller. So first is your Git, obviously the source code where you have your code checked in. Then you have the source controller, and then you have the Helm controller for Helm repositories, and customize for the customize files for the manifest which are there. And it is all, these are all taking the namespaces RBAC. They are using the Kubernetes API and all that stuff. So source controller is getting the manifest in the cluster and bundles them as artifacts. So these take and bundles them in the tar files. And how do we create them? By creating a custom resource. There are additional controllers on top of Helm. So if you want if you want to use a Helm instead of Git, then you obviously create a Helm object. If you want customize, you create a customize object. We'll see that in an example. And if you want, there are two additional controllers as well, which is called image reflector controller, that monitors the container registry. So you can actually monitor the container registries, and if any new stable image or any new tag is pushed or any new patch is pushed with respect to a particular release, then that can trigger the change, that can push the change in the GitHub repository. And then GitHub repository, how this will work. So you have a registry. Let me explain you. So you have Docker registry. Suppose there was an image Nginx 1. Now Nginx 2 got deployed or pushed to Docker registry. Now you have image reflector controller already object created, and which is monitoring the Nginx image and from the Docker hub. Now what happens is it gets that image, it pushes that artifact to your Git repository connected, and then source controller will take that from the Git repository and it will then deploy to the cluster. So that's how the states are sync between the Kubernetes cluster, Git, and stuff. And yeah, there is another one which is the image automation controller. Yeah, so image reflector controller gets that, and image automation controller will be committing to the repositories which are connected. So these two work like this. And yeah, this is how, like, the cluster operators, you define, you can define your cluster definitions, add-ons to that, and in different environments. And you can have that in Git, and you can maintain the cluster environments which is having Flux, so they all are maintained. So this is the clusters getting maintained. Now bootstrapping is a process where you bootstrap your GitHub repository or your and your what you call Flux inside your Kubernetes cluster. So it can be done using the Flux CLI or using the Terraform provider. So for example, Flux bootstrap GitHub owner, my user, repository, this branch, main, path, this particular path, personal. So this will bootstrap this particular Git repository with Flux components, and also it will install Flux inside the Kubernetes cluster. So these will be the components. So you have Helm controller, I told you, customize controller, source controller, notification controller is also there. There are these two controllers are not there because I have not defined them, the image and the image reflector and the automation. Where is it? Okay, you have deployments for all those, and you have services for all those, and this is what gets created on GitHub. Now let's see this in action. I'll show you. So I bootstrapped it, and it connected to GitHub. The repository got created, and then it cloned main from Git repository. It generated the component manifest, then committed the sync manifests and pushed back the components and installed the components onto the cluster, and then it generated the sync manifest and again pushed that. So all these things it has automatically done, and then it wait for all the customizations to be reconciled, whatever is pushed, and with the Flux in the Flux system namespace to the Git repository, everything is there, like Helm is ready, customize is ready, all these controls are ready. So it gives in the end like all components are healthy. And after this I do um cloning of the repository. So I do a git clone of the repository in my local system, and I create, now this is important, so I create a source which is called Flux create source git. So I am creating a Kubernetes object called git. I'll tell you like how it looks like. It is there only. And this is the URL. I'm taking it from one of the repositories and from this particular branch, and I'm exporting it in this particular file in my local. So this particular file on my local looks like this. So this is the YAML file. This is what I was telling you. You can define your own Kubernetes kind object. So Git repository is understood by Flux because there is a source controller present in the Flux system namespace on the Kubernetes cluster. So and it has the spec section is already populated because we have bootstrapped using the Flux command. So that's how it is. And then we again add the um, git add, and it gets pushed. And now what we create is customization. So we create a customization because we want to deploy that. So we create a customization. Target namespace is default, we want to deploy on default. Source is pod info, whatever we have created above. Path is dot slash customize, and then is the interval and all that stuff. So it creates a customization Kubernetes object, and it is understood by us, our cluster, because we have customization Kubernetes controller present in the Flux system namespace. So that's how it is there. And then I add that to the repository, and it is there. And when I do Flux kubectl get customizations, you can see both the Flux system and the pod info, they are here. This is the important because this is getting deployed. And yep, it is there. And if I kind of, what I did is just now I added in the, right now if you see kubectl deployments was 2 out of 2. And I think I made some changes. Let me get that and see if anything got changed, or it is picking up, or maybe I didn't change at all. I think I already did that change. So it is connected, and on the GitHub side, it is in this particular repository. So you can see here. So I have this was created like just a couple of hours ago. I created, so all the just all the things that were there. It is created like the source YAML. Okay, this is the source YAML which is there, the Git repository object, and this is the customization YAML which is there, which is being monitored. And then you have Flux system. In the Flux system namespace, you have all the fancy stuff. So yeah, I think that's particular. You can sync your repository, and you can have those kind of stuff. Okay, I didn't do a git push. Let me just do one thing. Let's see if anything got added. Yeah, I think I added this particular patch in the git repository. So let's see if something gets changed or updated. And the document that I followed is getting started with Flux. So pretty straightforward. And what else is there? There are a lot of use cases. Flux CLI, it is there, like how to use it, the toolkit components, all. What if you want to deep dive into any of the source controller, what it does. This I'm not covering because I'm totally covering the v2 Flux v2. And these are some of the use cases where it is getting used: GitHub action, manifest generation, PR. Yeah, another thing that I wanted to show is very interesting one, KubeCon 2021. So I gave a demo at KubeCon 2021, and I have this Flux thing which is there. So in the GitHub workflows, I kind of use a template to push to the local repository, and whenever I make some change in the source code, I push this to this particular repository, and the customization. So if you see the templates, not this one, in the, yeah, in the TMPL section, I have a Jinja template which gives me this particular deployment, and the image name is the image deploy tag, and this will always get kind of get replaced with the workflow ID which is there. And then in the Flux system namespace, I have a customization YAML file. Oh, sorry, this particular hello.yaml file. So this is a deployment, and this is a service which gets deployed. And what gets done is I then bootstrap, and here, yeah, if I use extra arguments, I can actually have other controllers as well. So here I'm using the image automation controller as well. So I'm bootstrapping Flux to use the deploy path, and with a new image. So anytime there is a new image, it will do, because it is using the Jinja template in the TMPL folder. So you have seen all the template which is there. So this is the Jinja template, and this is the one which is there. So that's how so I mean, one of the demos there as well, that if you want like end to end, you can watch the power level 9000 talk on YouTube, which is there on the CNCF YouTube channel. And what else? Yeah. So it has synced now the minimum replicas from 2 to went 3. So this is what that was done is increased the minimum replicas. So I patched, and I just pushed to git, and I did nothing else, and it automatically synced the cluster state with whatever I have mentioned over there. So I think that's pretty handy. And that's how the git and the Kubernetes cluster is getting synced. And you can also have GitHub actions, and do n number of stuffs with that, like I told you, like pushing the image, having the Jinja template, and then having the other controllers. And each time uh, code is pushed, new image is there, it is editing the deploy.yaml file, which is being synced with the Flux. So I think that makes it a complete package, how to use it. So with that, I think I'm kind of done with all three. So that's all. So that's what CNCF minutes look like. I covered three big projects. Actually, if I can go on for hours talking about any of them, because there is, right, Kubernetes training courses itself, they are for hours. So like this only, if I start the demo from the scratch and all that stuff, so you will be having all the, I mean, it'll take a lot of time. But CNCF minutes aims to kind of explain the project in few minutes. Like few minutes is not a couple of minutes. Obviously, it's like 8 minutes, 10 minutes, sometimes 11 minutes. So you will be having those. So there is a CNCF minutes playlist already there on my YouTube channel, which covers more than 19, 17 on 17, 18 projects. And I will be adding these three. So I have not added these three projects. These three projects were created for today's stream itself. So you are seeing it kind of exclusive over here. And after the stream, I'll create a separate CNCF minutes video for each of them, because I already have prepared the kind of architecture flow diagrams and whatever stuff I prepare in the CNCF format stuff, the fancy way. And I will create all three videos. But I hope you get the gist of Kubernetes. Obviously, You want to learn, go to Civo Academy, nothing better than that, because I myself have curated all the content. And then you go to for Falco, you have the labs, and you can use my kind of recording of this as a theory. And for Flux, there are a lot of deep dive videos that you can go through. If you want, like, you can tell me also, I'll create a deep dive one, and end-to-end workflow. I did the end-to-end workflow, but more detailed and complex workflow, kind of a real world scenario. We can do that as well. So with that, thank you, Ransi, for having me. And this was what I got for today.
Hey, sure. Thanks, Saiyam. I think that was like a super awesome, wonderful session. We thoroughly enjoyed that sort of a 10,000 feet overview, so to speak, of these projects. And I'm sure there were like many takeaways for all of who have tuned in as well. So thank you again. And it was super awesome to host you. So I'm not sure if we have like probably maybe 2 to 3 minutes more for some questions, if we have, right?
Yeah,
So,
I can take
yeah.
that.
So let me see if, yeah, so folks who are tuned in, this is like your chance to drop in your questions to Siam to pick his brain. And then on these three projects, and feel free to drop in. I already have a couple of them coming up. Maybe I can just pop that up on the screen. Uh, I mean, that was a wrong thing. Yeah. That's the feedback that I wanted to show you. And then the question that I have is, what's the difference between GitOps, GitLab, and GitHub?
So GitLab and GitHub basically are the source code repository. That is where your code lives. Now GitOps becomes like when you are having something which is connected to your infra layer as well. Like you are doing the operations from GitHub. You are, you are syncing between your deployments and GitHub. So you have something in GitHub and you commit something in GitHub, and it automatically, creates the files, manifests, and deploys onto your particular cluster. So that's where GitOps live.
Good, thank you. I think the next question coming up is from here. Is there like a GUI-based platform for monitoring Kubernetes objects or pods?
I think there are a lot of dashboards and lot of UI based tools. Rancher is there, Portainer is there. I recently made a video of Portainer walkthrough. You can go through that. Then what was the headlamp is there. Canines is there as your local command line stuff, which gives you a nice view of the cluster and pods and stuff. You have Lens, which is super cool. Gives you, detailed view of your cluster, objects, pods, replicas, edit on the fly, deploy on the fly. And then Monocle is there. Monocle also gives you this particular view. So I think a lot of them are there.
Cool. I guess that's pretty much it for the questions. We've pretty much late on time as well. So I think the session ran for an hour. So yeah. So with that, I'm gonna sign off, and thank you, Sayam. We hope to host you again in the near future. Again. All right.
Sure. Thank you for having me.